100.
Right.
So what we can't say is that it's bigger than 100 or less than 100. And these are typically your claims. So what we like, here's what you really want. You really want the number to be outside the confidence interval, because then you can reject.
Okay.
You know, either bottom or top. You know, then you can reject. But because it sits inside there, you cannot reject. Okay.
Okay.
And that tells you that the p-value, this is that whole thing, you reject when the p-value is less than or equal to alpha. Since you cannot reject, we know that the p-value must be greater than alpha.
Okay.
And that means do not reject.
Do not reject.
So that's C and D. And then do not reject. Looks like it's letter D here.
It's letter D. So the p-value is greater than 10 and HO should not be rejected. Okay.
They go hand in hand.
It's greater than 0.10. Okay.
If it was like the only ones that are even possible are A and D, because the p-value less than 0.1 means you reject H0.
Okay.
The p-value greater than 0.1, you do not reject. The other ones are garbage. They're not. They're just there to be.
You know,
So you've got to get really comfortable with this whole p-value less than alpha, reject. P-value less than alpha, reject. You know, that like you wake up in the morning, p-value less than alpha, reject.
Okay. Okay. Good to know. P-value less than alpha, reject. Or equal to.
Yeah, some books are less than or equal to. This is just a less than or greater than. I mean, I usually just show it as less than.
Okay.
But
okay. Cool. And then whichever
yeah.
one's most.
All right. So there's this. These are very wordy.
Yes, they are a little bit.
Okay, so test taking strategy here is you go right to this right here. I teach an SAT prep class, and this is what I call the call to action. This is the thing that you want to read first down here. Which of the following is the best interpretation of the slope of the regression line? Because it may be that there's nothing here that you care about reading or need to read.
Okay.
So you're interested in the slope. The slope is 0.48. And notice I have not read any of this other stuff.
Right.
Okay. Now, what does that tell us? It tells us there's a few answers over here we can actually get rid of.
Okay.
This is also a test taking strategy. Anything that doesn't have 0.48 in it is probably gone here.
Okay.
The height increase on average by 0.29. Nope. By 4. Nope. Okay. So we're looking at A, B, or E. The height increases on average by 1 meter each 0.48 years. The height increases on average by 0.8 meters each year. What do you think when you read those two?
Height increases on average by 1 meter each 4.8 year, and then the height increase on average by 0.48 meter each year. Okay. What do I think? Like what
Yeah, well, which way you're leaning, or if you're not sure, you know, tell me what's the same or different
I was
about
leaning
them.
towards B a little bit more.
It is B.
It is B. Okay, because I was
Yes.
going to say like it doesn't mention like by 1 meter each year, and
That's right.
the 0.48 is right next to the age as well. So
yes. So the test taking strategy here is read this thing first.
Read that thing first. So kind of like start from the bottom up.
Right. So there's two things you can do. Because it's a which of the following, which is a fairly standard question, you do have to scan the answers. And when you scan the answers, you look for what's the same and what's different. Now, because we could quickly look at the slope and know that it's 0.48, that allows you to eliminate some, which helps. And I still haven't read all this. I mean, I don't care that it's an Australian pine or a regression equation. This is distracting and time consuming. In fact, none of this is needed.
Okay.
But to your point though, you generally start here at the last sentence, what I call the call to action. And if you need to, you go back.
Okay.
But only if you need to.
Right. Yeah. And with usually that, I kind of like whenever I look through the question, I just kind of scan for numbers that like if there are numbers in like a big text like that need to be underlined or like are important in some way. Like real quickly.
That is good. That is good. All right, so here's another question here. All right, so again, let's go down here and look at this. Let me grab the answers here. All right. Suppose let's go be further. What is the mean cost per customer for the performance? Okay,
Okay.
was the mean cost per customer for the performance? So what I when I see this, I see, okay, I've got to find the mean of this right here.
Okay.
But it says each ticket costs $12. So this one's a little bit more involved here. You might want to go back and read this. Everything in this top part, though, is just
Yeah.
describing what's in here, this table.
Okay.
It says relative frequency, number of tickets purchased. How would you find the mean of this table?
Find the mean of it.
Yeah, and this is X and this is F. Or I'm sorry, this is P of X, sorry.
P of X.
X and P of X.
Okay. So don't you, hold on, was it add up the bottom ones with times the how many there are, or no?
Do you guys get an equation sheet before I answer that?
Oh,
On the AP,
formula
AP,
sheet. Yeah.
I don't really remember. Do you have a link to that or something? I
Uh,
can do a quick search for that too.
yeah. I don't think I have it with me right now. Yeah.
All right, quick search reveals from 2020. I don't know if this is relevant. I'll drop this in the chat.
The
I mean,
one that we got was from 2019, so I think
okay.
it should be all right.
All right. So trying to find the best. Yeah, I guess I'll show it this way. So the problem is that even if I show you the formula, it's like, well, what does that even mean? So that's why
Right.
it's like, well, do I remember the formula and do I know where it is? This is on page 1, kind of more towards the top. The formula is you take the sum, this word means sum, of X times P of X.
X times P of X.
So what I do is I sit here and say, okay, 1 times 0.2, and I put the result there. 2 times 0.45, 0.9. 3 times 0.1, 0.3. 4 times 0.2 is 0.8. 5 times 0.05 is 0.25. You're going to add these together.
I see.
Okay, that is not the answer though. That's intermediate
That's a
step.
setup. Yeah.
1.1, 1.4, 2.45. So it looks like, yes, the first answer there's 2.45.
Okay.
Now, letter A, another test taking strategy, is like what I call it the most common wrong answer. It's typically an intermediate step. It's like you get a number, you're like, oh, it's my number, that's my answer. Maybe. You got to be really careful. If it's A, you got to sit there and decide, is it A because it's actually A, or is it A because it's an intermediate answer and they want me to choose A?
Right.
And that's what it is in this case, because what this number represents is the mean number of tickets purchased. Like the average person, I mean, this is impossible. They purchased 2.45 tickets.
Okay.
Okay. And what we want here is the mean cost, the money. So how do we convert tickets to money? We multiply by the cost of the ticket.
Okay. 12 times 2. So that'd be 20. Just pull up the calculator. $29.4. There you go.
Okay.
Wow.
So the main thing when you see a table, we did some of this, the standard deviation is worth doing.
Okay.
Or variance. So I don't like, they give you that formula. That's not good. That's not the best one to use. So the variance is the expected value of X squared minus the expected value of X squared. Have you seen this before?
No, I can't say I have.
Have you seen the one where it's XI minus X bar squared?
Yes, I've seen that one.
Oh, okay. It's
this
ways away from.
On that one.
Yeah, this is a lot faster. I used to be a big proponent of this one, and then just through years of working with students, I realized this is a lot better.
Okay.
But you often are asked for the variance as well. So you got to be comfortable doing that. You got to take this 2.45, subtract each of the X values from it, square it, multiply by the P of X. Now this
Right.
can all be done in lists. Do you want us to spend any time like going through that on the list here? I've got a virtual calculator if you want, or we can move on to some more questions, up to you.
Sure. I mean, I feel like I should probably learn a little bit more about the calculator.
Okay.
I'm cool with doing the lists.
All right. So get your calculator out, go to a stat, edit, list one. I'm going to get this thing loaded as quickly as I can.
Oops. Edit list one. Okay, and then we just plug in the.
Put in 1, 2, 3, 4, 5 in list one, and then 0.2, 0.45, 0.1, 0.2, 0.05 in list two. And I'll get caught up here pretty quick. So I get this thing up. There it is. Okay. So if you see my screen, you're seeing a stat, edit, list one. And then all right, you got that got that entered?
Yeah, 1 second. 0.25. Okay, I got it.
Okay, so real quick shortcut here. Let's just say you wanted to clear out list one. Okay, and don't just watch me do this because it does take up time. You go up to L1, you hit clear and then enter, and that will remove everything rather than removing it line by
Right,
line
like I
there.
go like delete.
Yes, which can get annoying. Now, you can also do calculations on lists, but you got to go up to the top there. So here I'm at L3 and see how there's a little equal sign there.
Yeah.
So we want to get the product of list one and list two. To do that, we go second L1. See how it populated a little L1 there?
Oh yeah.
Times second L2.
Okay.
So when we hit enter, and don't hit enter quite yet, it will populate the list there with the multiplication of it. Okay. Now, so what you want to do before you hit enter is just make sure your formula is correct, because here's what happened when you hit enter and you go back up, your formula is gone.
I see.
So you don't know what you did. You're like, I don't know what I did.
Okay.
Remember, calculator only does what you tell it to do.
Right, right.
So now if we wanted, so if we real quick here, we quit out of this. And if we wanted to get the sum of that, I believe that's under stat calc. Not there. There's somewhere where there's a sum function. Really not finding it here. There's a sum function somewhere in your calculator, and you can take the sum of L1. Oh, sorry. Here's how we do it. Stat calc one variable stats. Stat calc one variable stats, and then grab list three, because that's the one we calculated. And then the sigma X is your expected value. See that there?
Okay.
All right.
That calc. So then just put in list three instead of list one.
Right. Now using an 84.
Yes, I'm using an 84.
Oh, good.
I just got it today. So.
Does it have a, like when you did a stat calc one variable stats, did it give you like a little screen that said like list one or list frequency?
Yeah, it says list and then frequency list and then calculate.
Good, good. Okay, so that's even better. That's even better. What you can do in this particular problem is you can, in your one variable stats, you can actually use list one as your data and no, you can't do that. I'm sorry. Well, this will not do that.
Oh, okay.
Sorry. If you had actual frequencies, if you had like 4, 5, 6, 7, 8,
I see.
then you could use it. But when they're probabilities, no, can't do that.
Gotcha. Okay.
Okay, let's go back to the list. And we're going to go over to L4. Okay, so this is where we're going to do the expected value. So remember, it's the X values, which are in list one, subtracting the average. So we know the average is 2.45. We calculated that. We're going to square that. Okay, this is the xi minus x bar squared part of that formula.
Yeah.
Times list 2, because that's got your frequencies in there for probabilities.
Right.
So if you don't like this, I don't know what to tell you, but this is like what you got. You don't have like nice modern technology. You got a calculator, but it is faster if you're comfortable using it. Again,
Honestly, like, yeah, I'm fine with that. I don't mean to interrupt, but yeah, this is cool for sure.
okay. Again, it does not save the formula, so really make sure you got it right, because you'll just have to redo it. Hit enter, gives you a bunch of numbers again. To find the variance, you need the sum of that list. So to do that, you go back to stat, calc, one variable stats, list 4, and then you look for the sum. The sum of that is your variance.
That would be the sum x. Oh,
Yeah,
okay, yeah,
sigma
1,
x.
2, 4, 5, 7. Okay.
And then if you want standard deviation, you take the square root of that.
Okay, the square root of that.
There's other ways to do this. This is, I guess, my best attempt at showing you that.
Oh yeah, no, this is great. For sure, like definitely like in our classes, she uses the calculator quite frequently. So like
Cool.
with the shortcuts and all that, because like the time crunch of the test and all that.
Yes. So you have to decide whether you have enough time to do it or it's faster by hand. Those are tough questions to answer. All right, so let's go to this next one, a survey of a random sample of something. All right. Let me go back and share my other screen. Just a reminder, I do upload these to my YouTube channel. So if you ever didn't catch something, just go there and check it out.
Yeah. And I can find the YouTube on the website, right?
Yep.
Cool. Perfect.
All right, let's go down here. How many males and females in the sample would be expected to brush their teeth at least twice a day? So we have no idea what that means. We got to go back and read.
Right.
Random sample of 210 male, 228 female. Not important. Found that 122 of the male, so like 122 out of 210.
Okay.
And 160 of the female, 160 out of 228. Brush their teeth at least twice a day. All right.
No.
If there's no difference between the proportions in the population of all males and females, brush their teeth at least twice. Approximately how many males and females in the sample would be expected to brush their teeth at least twice a day? So I'm having a hard time not just using those numbers as is.
As is, yeah, like the 122 and 160.
Yeah. Because that's at least twice a day, at least twice a day.
No difference between the portion and brush their teeth at least twice a day, approximately.
Did you say you have the answers?
No, I don't have the answers for this one. I'm sorry. These are just like random ones I found online, but I couldn't find like the answer key for it.
All right, let me see if I've got a way to confirm that it is as simple as we're kind of making it out to be.
Could it be more complicated than that? Like, is there like another thing you would have to plug those numbers into?
I mean, initially it's a 2 sample proportion.
Okay.
But that's more involved, and your answers here are not. Yeah, so I got this. Cheg's got this. Let's see if this is upvoted or not. No votes. Yeah, this one's not giving me.
No, it's all good. We can skip it. Oh, I'm pretty sure. Yeah, I think that we can go with that for now, because I mean they're not giving us too much else to work with.
Yeah, the keyword, there's something here. It says if there's no difference between the proportion of the populations, that's good to know. That might be something.
Okay.
There, I'm not really sure. The other things here's the other thing that you might see here, sometimes they have you calculate what's called a P bar, which is x1 plus x2 over n1 plus n2. So
Right.
in your problem, that'd be 122 plus 160 over 210 plus 228, but that's not, they're not asking for proportion here of the group. So I guess I would go B.
Yeah.
I don't like that. I'd like to spend a little more time on that, but we just, I'm not sure. These are good ones to ask in class, you know, hey, I worked on this problem.
Right.
I'm
Right.
not sure. I'm not sure. I want to know if it's B. If it's not, I want to know why, because I'm not sure what I'm missing to be
Okay.
able to make that determination.
Yeah, sure. I'll bring it up in class, see what they say.
Yeah. Have you had a chance to talk to your teacher and kind of find out where you stand there in the class?
Yeah, a little